Welcome all to Kinematics class 1. So in this, basically we'll discuss about distance and displacement. So the major portion in 11th class physics is related to a topic known as nothing but mechanics. This mechanics is nothing but the branch of physics which deals with the motion of an object. It is further classified into two. One is known as kinematics and another part is known as nothing but dynamics. So kinematics is nothing but the branch of physics which deals with the motion of an object, same as like mechanics, but it is without considering the cause which produces the motion. That means the particle is moving, the particle is accelerating, or a particle may move with a constant velocity. So we'll observe what about displacement, velocity, acceleration, etc. But we will not find out why the particle is accelerating or why the particle is moving with a constant velocity. So we are not considering the reason for it. So that is known as something about kinematics. Now the next part, which is known as something about dynamics. It is a branch of physics which deals with the motion of an object with considering the cause which produces it. So if a particle is accelerating maybe because of force, so we'll find out what about the value of force, and the particle is moving with some angular acceleration maybe because of torque, we'll find out what about the value of torque, etc. So in the first part of kinematics, we'll discuss about just distance and displacement. We know that if an object is starting from point A, and assume that it's moving through a path something like this, and after some times it reaches the point B. So over here, what about the total length of the path? Means if you're finding out what about the length of this path, that will give the value of distance traveled by the object. At the same time, we know that if you are just drawing a straight line starting from initial point to final point, so this is going to give the minimum possible distance or the shortest distance between point A and B, and that will give the value of displacement. So the magnitude of displacement is nothing but the length of this line, or we can say that it is the shortest distance between initial point and final point, and distance is nothing but the length of the path traveled by the object. And this distance is a scalar quantity, but displacement is a vector quantity. So we should specify what about the direction of this displacement. The direction of displacement is always from initial point to final point. So this is representing the direction of displacement. Now from the diagram, we know that the magnitude of displacement is less than the magnitude of distance. And if you are considering a situation in which the particle is moving in a straight line, so the magnitude of distance and the displacement can have a same value. So we can say that this distance is always greater than or equal to that of displacement. I'm talking about the magnitude. So the magnitude of distance is always greater than or equal to that of displacement. The magnitude of displacement cannot be greater than that of distance. Another important thing is, as displacement is a vector quantity, it can have a positive, negative or zero values, but distance is a scalar quantity, so it will always have a positive values. That means if an object is starting from point A and after some times it reaches the point B, let's say distance from A to B is nothing but 4. So in this path A to B, we can write distance is equal to 4 and displacement is also equal to 4. Assume that after some times the particle reach point C and the distance from B to C is equal to, take it as 3. So over here we can say that the length of the path traveled by the object is 4 plus 3, that is equal to 7. So we can write distance is equal to 7. And but if you are talking about the displacement, that is the distance from initial to final point, so according to Pythagoras theorem, we know that we will get this is equal to 5. So displacement is equal to 5. And assume that after some time is a point reach at point D, so it is going to travel an additional distance 4. So we can write the total distance traveled by this one will be equal to nothing but 4 plus 3, which is 7. 7 plus 4, which is 11. So 11 will be the value of distance traveled by the object. And if you are talking about the displacement, that is the distance from initial to final point, and that will be equal to 3. Now if you are talking about a situation when it is coming back to point A, so the total distance traveled by the object will be equal to, we can take it as 4 plus 3, that is 7, 7 plus 4, that is 11, plus 3, that is 14. So total distance traveled will be equal to 14, but it is coming back to the same point, so the value of displacement will be equal to 0. We can take another example like this. Assume that we are having a circle of radius r. If an object is starting from point A and after some times, let's say it reaches a point B, And if Rm is to find out the value of distance traveled and displacement, so we can write the value of distance traveled will be equal to 1 by 4th of its total circumference. So we can write its distance traveled will be equal to the length of this path, and you can write that distance will be equal to nothing but 2 pi r by 4, or you can take it as nothing but pi r divided by 2. But if you're talking about its displacement, which is the distance from initial point to final point, so we can say that this one is going to give the value of its displacement. And if this is r and this is also equal to radius r, so we can write this displacement according to Pythagoras theorem, that will be equal to root 2 times of r. Now after some times this object reached the point, let's say point C over here. So we can write the length of the path traveled by this one will be equal to half of its circumference, which will be equal to nothing but pi r. But if you're talking about its displacement, that is from initial point to final point, that will be equal to 2r. Now assume that after some times the point reach D. So over here you can say that total length of the path traveled by the object is 3 pi r by 2. And what about the displacement? That we can write distance from here to here. This is r and this is r. So this will be equal to root 2 times of r. And again, if the object reaches point A, so the value of displacement will be equal to 0 and distance will be equal to nothing but 2 pi r. So you can write the comparison between them. Distance, it is the length of the path traveled by an object, and displacement is the distance between initial and final point. And distance is a scalar quantity and displacement is a vector quantity, and the direction of displacement is always from initial point to final point. The magnitude of distance is always greater than or equal to that of displacement, and if the object is moving in a straight line, then the magnitude of displacement can be equal to that of distance. And as it is a scalar quantity, it is always positive, and displacement is a vector quantity, so it can have a positive value, negative value, or 0. That means if you are considering towards right side, is nothing but positive, and if the particle is moving towards left, we can write its displacement is negative. Or if the object is coming back to same point, we can write displacement is equal to 0. Hope so that you understood what is the distance and displacement. If you are having any doubt, or if you like to interact with me on live classes, or if you want to write test for JEE Mains, Advanced, or NEET, or if you want to solve more number of questions to improve your performance, please let me know. Thank you.